Hello and welcome. In this video we're going to look at the definition of inverse functions. I have two functions here that I'm proposing, maybe they're inverse functions of each other, and they're based on another function, h, that we're told is invertible. So I want to start just by reviewing what the definition, this is a key point. This question is focused on, do you understand the definition of an inverse function? And so let me just remind you what an inverse function is. And here we're told h is invertible. So invertible means that I've got a function and its inverse function. And if I use them in composition with each other, they cancel each other out. Okay? Now, it's not like algebra. It's not like reciprocals or addition and subtraction that cancel, but they're functions that cancel. So what's happening here is that our function is taking x. So in this picture, this x is an input, and h inverse, this function, creates some output value. And that value, h does something to that, and it creates yet another value. And the idea of inverses is that this puts me back at x. Okay? So when I have an inverse function, both compositions work. I've got h composed with h inverses, they cancel, and h inverse composed with h cancels. So the second one would be x is the input to h, that creates some other value, and then we take that, use the inverse function, and we end up coming back. So it's the effect of functions that are undoing one another. All right. So with that in mind, and I have two functions. My functions are f and g, and we want to see if they satisfy the definition of inverse functions. What that means is we need to look at, is it true or false that f when g of x is the input gives me x. And if I take g and use f of x as its input, does that just give me x? And I need to decide if these are true or false statements. So what does this mean? It means I need to do composition. I need to take this g of x and I'm going to replace it with, so g of x and this other formula, they're the same thing. So I'm going to say, well, if I take that h of x and I put it, if I put that g of x and I put that into my f function, so it's going to go in the spot where the x is, what do I get? So let's start it out. F with g of x as its input is equal to, well, what is the f function? It's 3 times what the h function creates, where you take twice its input, plus 1. And we're now going to replace g of x with its formula. Okay, so I need to think of this as a single object, and so I'm going to put it in parentheses as I do this next step. I get 3 times h, where the input of h is twice the quantity. Here's where the parentheses are. 1/2 of what h inverse gives me with x over 3 minus 1/2. Okay? And it helps me, I can use a little bit of color here to emphasize that these parentheses represent my g of x. And so this 2, I'm going to have to distribute. I'm going to have to distribute that 2 across to both of the terms. And when I do that, I discover f of g of x is 3 times what h gets, and I'm just simplifying what's inside. I'm going to distribute that 2, and I get h. Oh, I missed something. What did I miss? Let's fix this. So I didn't finish my definition, right? There's this extra plus 1 that's still inside of those h parentheses. All right, so that double leaves me h inverse with x over 3 minus 2 times a half is minus 1 plus 1. And the minus 1 plus 1 cancel so that I get 3 times h, where h has an input of h inverse, and h inverse has an input of x over 3. Well, here is the composition of inverse functions. And so this is where that composition shows up. Whatever is their input is all that survives. This is the cancellation that those functions cancel. And it's not like algebra, it's composition canceling. And so what do I get? I get 3 times x divided by 3. 3's cancel, and I get x. So the first question is yes, f of g of x is equal to x. And the second, let's do that one now. G with f of x as its input. All right, so this time f of x is my input, and so I'm going to replace f of x by its formula. And g, I'll use what it says. G takes 1/2 of the inverse of h with its input, f of x, over 3, minus 1/2. Okay, and here's where we replace my f of x with its formula. So what is the f of x formula? It is, let's write this down, h inverse 3h of 2x plus 1. So that's my f of x, divided by 3, and subtract 1/2. Sorry, I was running out of space there. All right, so when I look inside the parentheses, right, this is where my h of x, or my f of x was. I should have done blue, I guess. Right, so this is my f of x, and inside these parentheses, notice h and h inverse do not cancel yet, because h inverse does not have h as its input, it has some formula. But the 3 cancels, so that I get 1/2, it doesn't look very good, 1/2, h inverse is the function that gets as its input h of 2x plus 1. Aha, there's my inverse composition. And then I'm going to subtract 1/2. So now it's h inverse of h of a formula. They cancel. And I get 1/2 of 2x plus 1 minus 1/2. And so when I distribute that 1/2, I get 1/2 times 2x is x plus 1/2 minus 1/2. And I get x. And so the second question is also yes. And if both of these compositions are equal to x, they're inverse functions. And so the answer is yes. G and f, G is the inverse of f.